Hey everyone, welcome. So, you're getting ready for your SPM chemistry exam, right? Well, you are in exactly the right spot. We're going to tackle polymers today. And let me tell you, this topic is a guaranteed feature on your paper. It's basically a gold mine for marks, but only if you know the secrets. So, let's just jump straight into it. Okay, but first, a quick tip before we really get going. You know I always say this, right? The best way to lock in what you learn is to practice. So you've got to check out www.mcqspem.com. It's loaded with SPM-style questions that'll get you totally exam ready. Oh, and there's an app too, the MCQ SPM app on the Google Play Store. Seriously, just use your phone to scan the QR code on the screen and get on it. It's a game changer. All right, polymers, I know, all those long names, the confusing structures, it can feel like a total headache. But trust me, we're going to make it simple. By the time we're done here, all those core ideas are going to be crystal clear. We'll just take it step by step. So, first things first, the basics. You can't really get polymers until you know what they're actually made from. It really just boils down to three key words. First, you've got your monomer. Think of it as just one single basic building block. Now, when you link a whole bunch of these monomers together, you get a polymer, which is just a fancy word for a giant, super long molecule chain. And the process, the action of linking them, that's polymerization. Simple as that. And if that still sounds a bit abstract, think about Lego bricks. Seriously, it's the perfect analogy. One single Lego brick, that's your monomer. Now, what do you do with Legos? You click them together, right? That long chain of bricks you just made, that's the polymer. And the act of you clicking them all together, yep, that's polymerization. We're just building huge things from tiny repeating pieces. And here's the cool part. These long chains are literally everywhere. Some are natural. Think about the starch in the rice or bread you eat. That's just a massive chain of glucose monomers all linked up. And then you have the synthetic ones, the man-made kind. And these are what we usually just call plastics. The polyethylene in plastic bags, the PVC in pipes, it's all polymers. Okay, so how do we actually make them? Now we're getting into the real chemistry, the stuff that's going to be all over your exam. There are two main ways to build these chains, addition and condensation. And you absolutely 100% have to know the difference. This is a big one. So what is the difference, really? Honestly, this is where so many students trip up in the exam. They get addition and condensation mixed up and lose easy marks. But that's not going to be you. By the end of this section, you'll have it down cold, I promise. Okay, let's start with addition polymerization. Now listen up because this is your number one clue, your big hint at any exam question. You need to be looking for one thing, a carbon-carbon double bond. That C equals C right there in the ethene monomer, that's the whole secret. It's the key ingredient. And then check out what happens. That double bond literally pops open. It's like it holds out two hands ready to grab onto the next monomer. And they just link up one after another, end to end, forming this long single bonded chain. And here's the most important part. Nothing gets lost. Every single atom from the monomer is now part of the polymer. It's a pure addition, hence the name. Okay, now let's switch gears to condensation polymerization. This is a whole different ballgame. The first clue is that you're usually dealing with two different kinds of monomers. And when they join together, when they condense, something gets kicked out. A small molecule, usually just water, H2O, is eliminated. Think about it. That means the final polymer actually has fewer atoms than all the little monomers you started with. So let's put it side by side. This is the stuff you gotta burn into your brain. For addition, remember, one type of monomer, and it must have that C double bond. And importantly, no byproduct. Nothing is lost. For condensation, you're looking for at least two different monomers, and you always get a small molecule like water as a byproduct. Seriously, pause and screenshot this table if you have to. It's your cheat sheet for the exam. All right, so we know how they're made, but what are they like? Let's get into their personalities, so to speak. This is another classic exam area, how plastics behave when you heat them up. Here's a question for you. Have you ever wondered why your plastic water bottle can be recycled, but something like, say, the handle of a frying pan can't be? It just burns? Well, the answer is all in the chemistry, and it perfectly explains the difference between thermoplastics and thermosetting polymers. Okay, look closely at this diagram. This is straight out of a past SPM paper. See those lines connecting the long chains? Those are called crosslinks, and they are everything. When you see this in an exam, a little alarm should go off in your head. Crosslinks mean thermosetting polymer. These links are like superglue holding the chains together. They lock everything in place, which is why you can't melt and remold it. So let's break this down. Thermoplastics. Think of cooked spaghetti. The chains are long, but they're held together by weak forces. You can heat them up, and the chains can slide past each other. That's why you can melt them, remold them, and recycle them. But thermosets, they're more like a net. Those strong crosslinks make them super rigid and strong. Once you make it, it's set for life. If you try to heat it, it won't melt, it'll just char and burn. Okay, we have gone through a lot of information, but if you only remember one thing from this entire explainer, if there's one tip that's going to save you in the exam, this is it. Here it is, your exam tip. When you're staring at a polymerization question, just be a detective. Your first mission, hunt for a C equals C double bond. If you find it, boom, it's addition. If you don't see one, look for your other clues. Are there two different monomers? Is a tiny molecule like water being kicked out? If yes, then it's got to be condensation. That's the whole game right there. And that's a wrap. You now have the key ideas you need to absolutely nail the polymer questions on your SPM paper. But for a final challenge, just look around you right now. How many polymers can you spot in the next minute? Your clothes, your chair, your pen, they're everywhere. Once you see them, you can't unsee them. They're the hidden building blocks of our entire world. Now go ace that exam. Good luck!